Let's test this claim. The claim that the proportion of males with blue eyes is the same as the proportion of females with blue eyes. And we now have the data sets collected from the class. So what you want to pay attention to is the with blue eyes and without. So this would be considered as the other category. And so there are two columns of browns. They should be combined together. So let's quickly check the requirements. The number of successes in female group is 5, and the number of failures is 11 minus 5, which is 6. So therefore that is satisfied, both 5 or large. And then for the male, 9 is the number of successes. 22 minus 9, which is 13, which is also greater than 5. So therefore we are good there. Let's test this claim using 3 methods: p-value, critical region, critical value, and confidence interval method. And so let's go to the next slide. First of all, let's convert the claim into symbolic form, because it says the proportion of males. I'm going to call the male as first population. P1 means the proportion of males with blue eyes is the same, which means equal to the proportion of female with blue eyes. So that's my HO. Keep in mind this is my claim. And therefore H1 is P1 not equal to P2. In stats disk, I should pick the alternative hypothesis as population proportion 1 not equal to the second one. And for the sample 1, I have 22, which is the male, right? Total male. Successes is the number of blue students with blue eyes, so 9. For the population 2, sample 2, 11 is the sample size, 5 is the number of successes, and this is the output. Okay. Now here's the output. Let's test the hypothesis using the p-value method. The so-called p-value method, I have to look at the p-value, which is 0.08. So the p-value is equal to 0.80. I said it wrong. I said 0.08. It's 0.80. And it is less than the significance level that we use, which is don't know what I'm thinking. So it's actually greater than, right? Greater than the significance level 0.05. The P is high, the null will fly. So therefore we should not reject the null. If you recall, the null is P1 equals P2, which is the claim. So therefore we fail to reject HO, and we conclude that there is no evidence. There's no enough evidence, right, to reject the claim. That the P1 is equal to P2. So the proportion of males with blue eyes is same as the proportion of female with blue eyes, right? That's what it is. So that's the p-value method. How do we do critical value, critical region method? First of all, I have to look at what distribution that I should draw. This is a Z distribution. That means it's a standard normal distribution. I should draw this shape. And then this is center is 0. Now I have to identify which region is critical region, which one is non-critical region. That's where this critical value comes in. There are two critical values. One is positive 1.96. The other one is negative 1.96. And this is a two-tailed test because my H1 is P1 is not equal to P2, right? That's a two-tailed test. So therefore, on both tails, these two tails will be so-called the critical region. Critical region. They're both critical regions. So both, okay? Both. And in between, that's where the non-critical region is. Critical region means the rejection region. Non-critical region means you fail to reject. Now, time to take a look at the test statistic. So which is negative 0.25, right? So the test statistic is negative 0.25. Where's that located? It's located in here, right? Negative somewhere here, which is the non-critical region. So I will write my solution as, since the test statistic z equals negative 0.25 is in the non-critical region, therefore fail to reject HO, and you make the same final conclusion. That's the critical value critical region method. Let's take a look at the last method, which is the confidence interval method. If you recall, HO is P1 equals P2. That's my claim. And H1 is P1 not equal to P2, right? So now confidence interval method means you have to look at the confidence interval, which is this guy. It is, so your confidence interval is negative 0.4 to about 0.3, right? That's what the confidence interval is. Now, confidence interval is a interval that you are pretty confident about the population parameter, and this P1 minus P2 is the same as saying P1 equals P2 is the same as saying P1 minus P2 is equal to 0. So now this confidence interval is for the difference P1 minus P2, and obviously 0 is one of the values that we are pretty confident about because it's inside this confidence interval. So therefore, this is something that we are confident about, right? So therefore, we should not reject that. So because of that reason, I'm going to say, since 0 is included in this confidence interval, therefore, we fail to reject HO, which means if this confidence interval, say hypothetically, suppose this is the confidence interval, negative 1, okay, and 0 is not in it, 0 is not a number that we are confident about, right? In this case, we should reject it. So you only reject HO when the value being tested is not inside the interval. All right, that's it.